Good evening, ladies and gentlemen. My job here is to act as the modern equivalent of a medieval herald. I'm here to announce the arrival of the great and the good, all the way from California. People with impeccable credentials, particularly in IIT, because 3 out of 4 of them went to MIT, and the 4th person is a nuclear physicist and biomedical engineer. I, of course, am a lowly IIT reject. I failed to get into IIT and ran away from home and walked around the dusty plains of North India. So this discussion will be moderated by someone far more qualified than me. It will be none other than my namesake, Atul. Without further ado, let me thank the Shastrarth Socratic Society that has organized this event. Before you think, what is this mealy mouthful of a society all about, I'd like to take you back into history. If you go back to ancient Greece, there was a Socratic tradition. And the Socratic tradition was based on inquiry, on critical thinking, on evidence, on rigor. And through a rigorous examination of the most fundamental assumptions, you acquired a better understanding of truth and reality. Exactly at the same time, or perhaps a little before that time, on this side of the world, we had a tradition of Shastrarth. Shastra means knowledge, Arth means meaning. And Shastrarth was literally a back and forth, a discussion, an examination, a questioning of fundamental tenets and principles that led to a similar result as the Socratic discussion, as the Socratic dialogue. And the very name of the society is holistic. It is Catholic, not in the sense of the church, of course. It is an acknowledgement that much of the world today is a product of influences of both the East and the West, the proverbial East and the West. And in this society, we seek to merge the best traditions of humanity and have discussions that are meaningful and the most salient issues that the planet faces. And today we have 4 people who have flown in from California all the way to Gujarat. Both these places have a lot of similarities. Both are on the West Coast. Both places are entrepreneurial. And both places are arid. They both have a bit of a water problem. And ipso facto, I suspect both places have a lot to learn from each other. This is the land of Gandhi. This is the land of strong family ties, a very deep tradition of community, and of course, deep in its DNA with its Jain traditions and its belief in ahimsa, a strong commitment to sustainability. Today, on the other side of the world, California, despite Hollywood and Silicon Valley, is discovering yoga, meditation, and all that jazz. And they too are grappling with issues of marrying efficiency with equity, technology which is human-centered, fairness, justice, sustainability at all. And now, given you a prologue, I will invite the august members or the august panelists, Cody Daniel, who is someone who has driven an auto all the way from Jaisalmer to Kochi, Ohio chap, machinist, mechanical engineer, who's trained under Sanjay Sarma, an IITian in MIT. I'll invite him to the stage. I invite Camille Noyle, who is a nuclear physicist turned a PhD in biomedical engineering, who now works in oncology. I invite Dan Enge, who has worked in aeronautics, who's worked in generating clean energy through windmills, and who, when I introduced him in December as chef pilot engineer, said he would agree with the description, but he would reverse the order, which says a lot about him and a lot about his identity, his vision, and his desire to contribute to the world as an engineer. And finally, of course, I invite Emma Enge, and she is a rocket scientist who's worked in many organizations, including SpaceX. Ladies and gentlemen, invite everyone with a big hand to the dais, and I will leave you in safe hands with Atul and the rest.
Good afternoon again. So I guess we'll start with Cody. So Cody, how did you go from material science to power electronics? So can you take us through that journey and what you did and what are the key turning points that made from a material scientist to a power systems?
Yeah, absolutely. I was a very terrible student in that I couldn't keep a major for more than a year.
I think you need to hold it closer.
Yeah, can you hear me okay? There we go, that's a little better. Yeah, I was a very terrible student in that I couldn't keep a major for more than a year at MIT. I found myself with a lot of different interests and being pulled to a lot of different professors who I found very appealing and courses of study and what I thought would be interesting. So it's actually even more subtle. I started off in nuclear physics my first year because I thought I wanted to work in fusion power, and then I found out there was no future in fusion power, at least not in the next 2 decades. And that was a very sad time for me. I saw the biggest problems in fusion power were the materials, and so then I moved into material science. I liked the lab work. I really enjoyed the time there. But then as I learned more about materials, all the exciting research was in semiconductors and lasers and metallurgy, and so I started to move into power electronics as I learned about semiconductor work there. And then as I was in electronics, I found that the neatest applications of electronics tended to be mechatronics, building robots and automation and pushing that place forward. So I actually then moved into mechanical engineering. And I finished off with a degree that I made up. Fortunately, MIT can be very lenient on their creative types and understanding of people who don't follow a traditional path. And so I got to make a mechanical engineering degree that was a flexible mechanical engineering degree. And my focus was in machine design. And so that combined kind of the motion and matter. It combined these pieces of material science and metallurgy with the control systems and mechatronics to control them. And altogether, I studied instrument design. And that instrument design led into kind of the work I do today, which is designing new instrumentation, new tools for researchers and biologists to use. So it's a very meandering path through my undergraduate course at MIT. It was definitely a creative undertaking. But yeah, it was a good journey overall.
Maybe we'll go to Camille. So how did you go from nuclear physics or BS in physics to working for a medical device to now working on oncology? So
So first of all, thank you so much for hosting us. We're very excited to be here. And it's been fantastic to see the campus and meet everyone. And so a big thank you to you all. So my undergraduate degree was in physics, and I thought I wanted to do alternative energy. I thought about aerospace, and I did an internship in radiation oncology, so radiation physics. So I had a background in nuclear physics, and radiation oncology is the practice of treating cancer patients with high energy radiotherapy. And I never thought I would be in the medical field. I never thought that was something that suited me. I didn't, memorization wasn't very appealing to me, memorizing textbooks and such. I had much more of an affinity to learn equations and derive theory and such. And so that was what appealed to me. And I think what the turning point was for me is when you get a chance to leverage all of the things you learn in school, and you get to apply it to real life situations that impassion you, that's when the spark and the magic happens. And for me, that's when it happened for me. So I went into this radiation oncology clinic, and cancer patients coming in and out, and I learned that this was a very interesting field where I could apply my physics knowledge to real life problem, and not only a real life problem that was just kind of there in front of me, but something that is pervasive throughout all different communities, meaning oncology, cancer, and touches people in a very human way. And so going from a scientist to kind of a more almost like a humanitarian perspective. The technology is incredibly interesting if you know anything about linear accelerators, which is my specialty. And so I worked in an oncology clinic for several years, went back to get my PhD in biomedical engineering, which was much more applied than a physics degree, I will say. And it was very interesting to me. I joined faculty for a few years after completing my PhD at Washington University in St. Louis. And I led some research that was funded by a company based in Silicon Valley. And they were very interested in hiring on a physicist engineer who understood the clinical problems, who was on the front line, who worked with cancer patients, and would be able to take that knowledge into industry and help define those problems in order to come up with better solutions for treating cancer. And so they recruited me to come on board, and I was very happy on the academic path. But I saw an opportunity where I could have further reach than I would have just being at the clinic that I was working at, which was a wonderful position. I had a director position there, and so I decided I would take a leap. And it was an education for me that ended up being far reaching than I could have expected. Silicon Valley is a very interesting environment in and of itself. And so as I joined onto this team working in industry, all the promises that I thought it would deliver, it did, and more so because then I was surrounded by this incredible community of people from MIT and beyond who were doing very, very interesting things in Silicon Valley. And you're in kind of this heartland of the place where a lot of innovation happens and sparks and has reaches its fingers out into other communities and globally. And so that is where it's brought me to now, and obviously it's brought me here to be able to spend time with you all. So for me, it really kind of was this kernel of interest in the sciences, and then that became spread through wanting to have an impact in a very human sense, to work with cancer patients. So
very nice. Yep. So I guess we'll move on to Emma. So you've done aerospace in your academics, and I guess you have stayed on in the aerospace field, but were there situations, were there projects that you worked on that surprised you in terms of what you needed to know? You might not have done that in your aerospace engineering education, but you needed to do that for your job. So I'm sure there have been situations that surprised you. So can you speak about those situations?
Of course. So one of my favorite quotes is actually in my thermodynamics book. It was basically this famous professor.
We need to close. Yeah.
Can you hear me now?
Yeah.
Basically, it was this famous professor, and he said that when he first read the thermodynamics book, he didn't understand any of it. It was very complex. He was like, what the heck is any of this? The second time he read it, he said, okay, I think I understand thermodynamics now. It just took a second read. And then he read it a third time, and he realized he didn't understand anything. And that's basically what it's like being an engineer. And that's what it's going to be like for our entire lives. You're just going to keep learning, and that's what makes you a good engineer. So I was lucky in that I received a lot of hands-on training for rocketry. You get to, I did my undergrad at MIT, and then I did my graduate studies at Purdue. And Purdue is in Indiana, and it only has corn and it has rockets, basically. But they have a beautiful rocket lab, and there you get to actually work and build one and test it and blow stuff up and retest it. So I learned a lot there, but it still didn't, I don't think it prepared me for working at industry level. So when I went to SpaceX, I mean, gosh, you think you understand things, and then you go there and you're just like, wait, we're supposed to launch something to space safely and not explode it? So there's just, you just don't understand what you don't know until you get out there. I mean, it's just the little things, you know, what fittings to use, how to seal things, and you just keep learning. And I was lucky enough to go there, and it's basically like a boot camp where they train you very quickly. You have to go from basically knowing nothing to being able to launch something to the ISS and not crash into the ISS, which is important. That's the International Space Station. So let's see, to think of an example.
Let's talk about fittings, you know. Just because you said fittings, so let's talk about fittings. So what was new in what you saw at SpaceX about fittings that you didn't know before? So by the way, fittings are those little things that you use to connect tubes. I think she'll talk about it.
Right, so my first time at SpaceX, I was an intern, and I had 1 year of being a master's student under my belt. So a lot of theory, some hands-on stuff, but I showed up, and you know, this guy is showing me the ropes, and he's like, okay, well, we have to build this valve, and we have to install stuff. And I said, okay, great. And he's like, so do you have any Teflon tape on you? And I said, why were we using Teflon tape? He's like, have you never used an NPT fitting before? You know, and that was my first time ever using that fitting, and now I've used it 1,000 times. I basically wrap some tape around something to seal it. Very similar to what you do in houses, which I'm learning now. So, yeah.
Is there a big difference between getting things to scale in an industrial setting where it needs to be repeated many times over versus the academic setting? Like what do you see that's different in something that's much more research oriented versus commercial?
Well, you see this throughout all of industry, basically. When SpaceX was first starting out, they had never built an engine before, and they were just learning how to do it. And there's a story, basically, where this guy, his name is Mark Cusick, he built their first engine, and he had the idea of maybe we should build spares, and like we should build an extra part each so that we know what the part should look like. At the time, there were no drawings. They literally hammered their nozzle into place with a large hammer by Tony. The guy's name is Tony.
Thanks, Tony.
Thanks, Tony. And that was just mind-blowing at the time. Oh, maybe we should make spares of stuff. But that you're still seeing these problems throughout all of industry. Like right now I work at a company called Stratolaunch, which is a Paul Allen company. Paul Allen helped make Microsoft with Bill Gates. He's the less famous of the duo. And he owns the largest airplane in the world, which the plan is to launch rockets off of it, basically. But we asked them, you know, how expensive is it to build this plane? And they said, oh, it's never going to be built again. We don't know how we built it still. So the industry is still learning this lesson. Yeah.
So, okay, so we'll move on to Dan. So Dan, how did you go from being astronautics, to being wind turbine? So wind turbine person. So can you talk about that? Yeah.
So I've always loved airplanes.
Maybe closer.
There we go. So
Yeah.
I've always loved airplanes, and at kind of a deep level. I think one of the reasons why I wanted to be an engineer was ultimately to work on airplanes. So when I went to school, it was kind of obvious what I would do. And I enrolled in the aeronautics and astronautics department and started to kind of learn the industry, learn what the jobs would be like. I also started to learn at that point some of the problems with air travel, with the energy usage in air travel, and just with energy usage in general. And my interest also became a little more specialized. So instead of just loving airplanes, I loved to work on fluid problems. I started to really enjoy applied math. I took a lot of applied math classes, and I began to wonder how I might be able to take some of those passions that I had and transfer them to start to think about and maybe solve this energy problem. And so wind turbines presented a sort of obvious opportunity. They're they have blades, they use the wind, they use aerodynamics. It seemed like a sort of cut and dry solution. And plus I thought, wind turbines are installed in places around the world that are, generally pretty beautiful. So I would travel some. I thought, this is great. I was imagining the perfect solution, I'm just going to love aeronautics, build wind turbines, save the world, get to travel, everything is good. And I took a wind turbine engineering class, and I learned that all of the problems in wind turbines are not actually in aeronautics. They exist in other places. And from that, I made a really, really good connection to my good friend Eric Smith. After I left school, I worked in a consulting company with him, and we were employed by VCs, venture capitalists, who were curious to understand what some of the major cost drivers in wind energy were, why wind energy was expensive and what limited the market penetration of wind energy worldwide. So then we hired some people and got to work trying to figure out what really, where the embodied costs in turbines and energy were. And what we discovered surprised us. We looked at blades, we looked at generation, we looked at transmission, we looked at construction, and we looked at the civil structure. And it turns out that the most of the cost is actually in the civil structure. It's primarily in the tower. The wind turbine tower is the single most expensive component of turbines. And so we set about to try to come up with a way to make that cheaper. And Eric had this brilliant idea that you could adapt conventional oil and gas welding machinery to autonomously make the tower. And so we tried to figure out how we could build that at scale. We had some great advisors in the mechanical engineering department, and ultimately started a company to do that.
Any questions from the audience about the background, their journey? If not, then I have sort of a related question. Yes.
Hi, good afternoon. This is Siddharth, finally a student here at IIT Gandhinagar. So my question is, the IIT system in India has been designed model after MIT, right? We have, it's designed to reach the same aspirations and the same kind of technological education to be provided to the students here. So all of you have had like great careers, and everyone's doing path-breaking work. So how did your life at MIT really design and push you forward along these? And do you think, say if you had, did your BS at some other university, you would have had the same kind of opportunities or same kind of, ideas that you have now?
Sure, I'll start. I would say that my time at MIT completely changed my life. And the most important thing I got out of my time there was the connections I made. MIT works hard to introduce you to new people, to help you get something called externships, which are internships with MIT grads. They really build this community for you to be a part of. And from that, it's something that you can rely on. It's something that you'll always have with you wherever you go. So I would say that that's my biggest takeaway from MIT, is just having these connections that it's given me.
I'll toss onto that. The three of us, Dan, Emma, and I, we all met in undergrad at MIT. So for a little background context, we're two married couples. Well, we're engaged, but they're married. Be married soon. And we own a house together. And thank you. We own a house together in the Bay Area in San Francisco, actually in Alameda across the water, where it's a little cheaper. And the fact that we all know each other and we're able to come together and do something difficult like buying a house in the Bay Area and working on this project together is born out of the fact that we met each other at MIT, got along, had time to get to know each other, had the space to develop a deep friendship. We've been friends for over a decade. Yeah, wow. Over a decade, 12 years now. And it's an incredible journey to go on with these people. I would say that MIT making a place where there's culture to play together in a very creative and engineering-like fashion is something that makes relationships that will last for your professional self and also your personal self for the rest of your life. One of the things I think we actually have more to learn in the US from India and from places like IIT is when I come to this campus, I mean, you all have only been here for a few years, and yet there's an incredible culture here, an incredible community. And maybe it's just a tool because he's very bombastic and charismatic, but when he takes me around campus, everyone knows his name, and he makes his very personal jokes at everyone's expense. And that's, and that's a wonderful thing. I love that there's that trust and that relationship, and it's present already. And already I'm meeting individuals who are saying, come back, come see IIT next year, come back to our conferences, come see what's happening here. And so you're already pushing forward that culture and community in a way that may have taken MIT quite a long time to develop. So I would say, like, don't worry so much about the academics. You will be a good engineer when you learn the process of learning. And it's a constant thing. As Emma said, you're always learning how to fail better. And that's just engineering. But the culture, the community, the friends, the network, that's what will make you successful in India and supporting the community that's around here in Gujarat and building up this place that's here. And you have so much opportunity to do that here.
I'll just add one caveat to that, which is that MIT is a grinder in terms of just loading you up and breaking you down. And yes, that process forces you very much to rely on the people close to you. So I think it accelerates lasting friendships, and it forces you to recognize and trust them, and then rely on them in a very.
You're giving a message here to the faculty to give more homeworks, I guess.
Sorry.
I think the community, that's the most important thing. And I think that's, for me, the opportunity of community that MIT has given, but also the lessons to rely on the community that you have has been most powerful.
Yeah, I actually do want to make a comment. So I did not attend MIT. It is amazing what a strong community. I can see it as an observer. MIT has on both coasts, but also, all over the world. And I feel very fortunate to have met this wonderful group of people, and not just here on stage, but we have a wonderful community in Silicon Valley. But one thing that's interesting is that, so I don't share that history. But what I do share is a common language as a physicist and as an engineer, and a passion for that with folks who I didn't go to school with. And I want to make that comment because I think it's really important to know that, yes, you have a community here, and it's these relationships you're making here, that commonality you'll have that throughout your life. But what's also important is that you can have a discussion with someone who went to a different university, but you have a common language and you have a common understanding of what those problems are. So I think it's really important to give credit to the foundations of learning engineering, learning the sciences, and knowing that you have that common language with someone who either is internal to your university or went to MIT or went elsewhere. And so it's really, really important to, I think, acknowledge that. And you can have those conversations no matter where you travel and no matter what campus you're on. So just to keep that in mind as well.
Yeah, that communication aspect is extremely important. I mean, all of these all the work that you will do is in context and relationship to other engineers, other people, other projects. And that's why you have these humanities professors here that give you such low grades on your writing projects.
So talking about campuses and education, there's this debate at many times as well as places whether we should have, what kind of curriculum is best for the students. Sometimes there are questions about whether we should have a broad-based education, which we do have today. So what we believe is to get the breadth through the coursework and possibly get depth in one or two areas by doing projects and internships and so on. So that's what our approach has been so far. How do you think this aspect gels with your career and what you have seen outside of the university? So what if someone came with very specialized know-how rather than know why? And how would they compare with somebody who knows why but doesn't know how so much? So
So at my company, one of the things that we would always look for when we were hiring people, or one of the things we would say to each other when we were hiring people was, we're not hiring for the job, we're hiring for the person. Primarily, we would want to know how that person thinks, how they approach problems, how they kind of break things down. And regardless of whether or not they have, extensive experience in one particular area or the other, we want to know that they can solve problems on their own, think critically and solve problems. And I think that comes from a broad education on the fundamentals. I think that comes from understanding sort of the commonality that exists in a lot of engineering fields, that understands how you can approach a problem and reduce it to its sort of constituents, and then sort of synthesize a solution from that. And so for us, for my company, that was extremely important. To kind of have that sort of fundamental knowledge.
Yeah.
So I have a lot of feelings about this, which I'll share with you. So one interesting thing about going down the PhD route, which is is a long haul. I remember making a decision if this is the pathway I wanted to go. And one of the things that was very appealing to me about going down that route was understanding that getting my doctorate degree wasn't necessarily to teach me specialization in a very focused fashion, which it did in certain regards. But it's learning how to think, learning how to solve problems. To underscore what Dan was saying. Learning how to take something that's broad and try to figure out, how to break it down and into components that are manageable, and then present what a solution would look like. And that's much different than memorizing textbooks, for example. So I think I think problem solving, there's a huge emphasis on that, and I think that comes with experience. I think it's the first couple years of schooling, it's you need to have understanding of the fundamentals. It's very, very important so that you can solve a broad set of problems. I think the other comment there is that from an industry perspective of hiring, the good companies will hire people for their ability to grow because they're in a growth mindset, right? So a company that can do pretty well at what it's doing and just kind of continue to trudge along might hire people for specific knowledge, but really the people they should be hiring for are people who can learn, and then people who have a growth mindset. And so it's really a balance between those fundamentals and then understanding how they apply to the world in a context that makes sense to you. So I remember, in my undergraduate work especially, I was learning some of these fundamental things, and I was in a physics program, and so it was very abstract. When I started understanding the applications, that's when it really started to gel for me. But I was so happy that I had these fundamentals, because then I was able to see one application and apply those fundamentals, understand how to deduce those fundamentals from that application, and then apply that to something that might be a little different. So I think that it's really a balance. I know that's it's a little bit of a wishy-washy answer, but I think it's really important. It's very important to have the fundamentals, but then you have to understand how it's relevant to you and how it applies to you. Would be my comment there.
Do you take that from the side of the faculty or from the student? That's kind of my question to you, is like, whose perspective are you talking from?
Which perspective?
You're saying like breadth versus depth in education. Mm-hmm. And do you mean like what program should you set up as the educators? Or like what this campus should aspire to? Or like what the students feel they want to, like what is more relevant to the students in their learning?
That's what I'm asking you. What kind of program would better prepare students for the career ahead? So that's my question.
Yeah, I think my experience has been that I've taken a very obviously I skipped around in the majors a lot. So for me, I obviously took a breadth approach, but it's actually a little more subtle than that. I took select little drops that were a little bit, one layer deeper in multiple subjects. And that meant that I did a little bit worse in each of them. But I accepted that because I felt like I was getting a little bit of a deeper insight into each of them. So they were kind of like these little pinpricks into multiple areas. What I felt about that is that I had a good background in systems, and I had a good background in just general how things worked. I grew up in a machine shop, in my father's machine shop, and so for me, I had a lot of intuition about machines, and that just came from lots of time hearing them and seeing them and feeling them. And so what I really wanted to get were these little, like, one layer deeper insights such that I could start to string together patterns from different fields. So being able to get a little bit of insight into how semiconductor doping is done, and being able to connect that to lessons I learned in my quantum mechanics course, and saying like, oh, okay, there are these neat similarities there. But then also seeing how that came out in power electronics when somebody describes a certain transistor type, and saying like, oh, okay, now I can see how these different things breach together. And if you hadn't taken each of those courses, you wouldn't know how, let's say, advances in control systems allowed for better control of semiconductor melts, and how those semiconductor melts led to better transistors, that then led to better power electronic circuitry, that then led to more efficient motor controllers, that ultimately led to the advent of things like the small drones, which also had this whole like attachment to the manufacturing world and like the development of cell phones. And so like I really liked having these like one layer deeper insights such that I could sort of see a broader pattern. But I think for me personally, that's because I really am drawn to the entrepreneurship side of the world. And for me in entrepreneurship, it's about looking out the field, the whole world, and saying like, what's not valued in the market? What's not being seen as something useful out there? In hiring, I much more tend to find people who are specialists, who really know something. Because I have a good sense of the breadth, and like I'm thinking about those pieces, but I'm not a very good specialist. You know, I can't design rocket nozzles or rocket injectors. Sorry, injectors, not nozzles. See, I already messed up the difference. But like, if you really need an injector designed, like you got to hire somebody who knows what the hell they're doing, and that's going to be her. And so for me, it's a balance. You know, again, it's a balance, and it's hard as a smaller young university. I imagine you're just getting started with your programs, and so you're saying, okay, what can we offer? And as students, you're saying, what should we demand and what should we take? And you definitely need to have both. And the question is really then, what's your mission? Like, what do you want to do with it? If you want to be the person that's relied upon, or you want to be a consultant, you want to be a freelance person, become a specialist, because I think knowing some one thing really well that you can do for lots of people is very powerful, and that's worked for you. If you're interested in entrepreneurship or seeing like kind of across the field, like become more breadth focused. I know that you've touched in many different fields between fuel cells and other things you had talked about when we were in your office earlier. So yeah, it's a kind of a mixed answer like you gave, but I think those insights might be helpful. I hope they're helpful.
In terms of education, you know, I think a lot of times the specialization that you're sort of talking about comes from like basically years of experience on the job. I mean, sort of to Emma's point here, you know, she didn't know what she didn't know until she started doing it, and then she didn't know it again, and then again, and then again. And you know, okay, sorry. But you know, it takes a long time to develop a real depth of knowledge in any one particular field, and I don't think it's reasonable to expect that any university program gives you that depth because you know, you don't know what you want to do when you first go to uni. So in you know, to sort of be able to succeed in whatever you might choose, whether it is either more a broad-based approach like you're talking about, or whether it is like a deep and focused approach, you really need to have the foundational knowledge first. So as a student, I mean, I would say focus on the foundation, because that will make you successful. That will allow you to be successful in whatever you choose to do. And if that is to do several different things, then that's great. And if that is to do one thing and then just really, really do it well, or if that's to go on and get your master's or get your PhD or work in academia, then you'll be prepared for it.
Yeah, and I think giving yourself your own space for that learning process. This is something, we had a smaller little session earlier, but having space for learning is a really important thing. Like overloading yourself with classes to know everything or to know one thing really deeply. If you're so stressed out and you don't have enough time to actually go through the learning process and learn how to learn, then you're never going to be able to apply that process later. And so you need to have space, whether it's in multiple subjects or one area. It's about developing that ability to learn time and time again. Because as Dan said, your life will be full of mistakes. So you just have to keep learning.
Yeah, talking about mistakes. So, so that's one thing that I wanted to talk about. So, how important is it to fail? Or rather, how scary is it to fail? And what do you do when you fail? Or did you guys not fail at all and you were always successful? So, maybe.
Oh, I have failed many times. That's what being an engineer is all about, right? I think if you work for a good company and the person that you are reporting to is a good boss, they will tell you if you're not breaking stuff, you're not doing it right. You're not actually pushing the boundaries to try to figure out the best it can be, right? If you're not breaking it, you're not really using it. Another thing that I've learned as an aerospace engineer is the best people, the people who understand the systems the best, only really understand it because they've broken every single part of it. And once they've broken this valve, they know, okay, here's what to do to not break it, or here's how to fix it, or here's how to improve it. So the next time something like that breaks, they gain that experience and they can fix it faster, or they can avoid the breaking all entirely. So I think failure is scary the first time you do it, or it's actually scarier before you fail anything. Once you like blow something up the first time, you realize it's not all that bad. You can rebuild, you can do everything. And you learn from those failures. And so once you've failed 50 times, it's a lot. You actually enjoy it. You're like, okay, let's learn from this. So.
Yes, I like to say there's no such thing as failure. I call them growth opportunities. And it really, it really goes back to what Emma says, which is that you only know what you don't know when you start pushing those boundaries and failing. For me, one of the things that was very enlightening, I have the good fortune, I think, of being in an industry where, the ending for the patients we treat is bad, right? This is it gives you a lot of perspective on what failure is, because as a physicist going into an oncology clinic, and being trained very much in tests and being graded and things like that, you go into the real world and you realize that, okay, having one failure is certainly not as bad as what some of these people are going through, and being in an oncology clinic. And so having that sort of perspective gives you some bravery to try things that you may not otherwise try because you're afraid to fail. So when you kind of have a perspective of, you all are young and bright, and really the world is your oyster. You're at the beginning of your journeys here. You have the freedom to make those failures and recover. You have more freedom to do that probably earlier in life than you do later in life. And so it's really important, I think, to not be afraid of that, to your question, because if you don't try, then you really never know what you're capable of. And this idea of reaching your full potential, again, is pushing against those things that that allow you to grow and shape who you are. And the other thing is, like, failure is considered a great thing in Silicon Valley. Fail fast, but fail often, and learn those lessons. And know it's really important to know what doesn't work for you personally. Just as important as it is to know what does work. Maybe even more important to know that. And so, I think that failure, like I said, is considered very much a good thing from the Silicon Valley aspect, but also I think personally, it can be translated personally, because it's what gives you a framework to think about what you do want to do and how you do want to spend your time.
I'll play on that just because it's easy to look up here. Secrets of success in Silicon Valley. Okay, like what does that mean? So you're familiar with Silicon Valley. It's this place with lots of research and development work and startups and glamorous stories told about it. But like the first part of that statement is actually much more interesting. Secrets of success. And I've thought a little bit about that as I was sitting here, listening to you speak about it. And one of the things that, what's failure in regards to? Well, it's the opposite of succeeding in something, right? So what's like, why do you call it a failure? Did you not meet your own goal? So one of the things I think about is research and development. Do any of you want to go into research and development? Is that a thing that any of you want to work in? Do you do research on campus? Yeah. So like the first part of research and development, research is all failure. You go into development once you found something that works, and then you start to develop it into something that's more meaningful. I think one of the secrets of success is learning how to frame failures for yourself. The first secret is saying, like, if I failed my expectation, but I was working honestly on what I thought the problem was, then that's a success in teaching myself about the problem. If you give it a go at some business and that business model doesn't work and it's not successful, that failure doesn't mean that you're a failure. There's no guilt about that. You went into it with all the right expectations, with all the right intuitions, and you explored whether or not that was a possibility. You gave research to some business idea or business proposition or some technology or whatever it was that you were trying out. And part of that research is accepting that many of those things will not work. Expect 90% of them not to work. And connecting that into the Silicon Valley model, the whole venture capital game, the whole story there is that it's about taking these big risks on different business models, on different technologies, and knowing that many of them are not going to work. But the few that do work will work very well. They'll find something that has not been touched on in the market, that has been very poorly assessed, that no one else gave value to. And those few things are extremely valuable nuggets to find. So the 90% of the cases that fail are just part of the model. That's part of the expectation that most of these experiments, most of these business experiments, most of these personal experiments are going to end in abject failure. And the important thing is to do it honestly, to do it with the best intentions, to go into it with a clear mind and plenty of space to think about it. And to understand that failure is also a personal success if you're doing it with the best intentions. If you're going into it and saying, I'm going to try really hard at this and see what comes out, then you can never really fail. It's always a success in doing honest work and doing good work and seeing the outcome. So in my personal life, in my business, we've had lots of failures along the way. We thought at first that we were going to work with neuroscientists and we would do lots of neuroscience imaging. It turns out neuroscientists have very little money because they're in neuroscience labs. They're not developing some blockbuster drug. They're not working with cancer patients who are dying. And one of the things is once you get started in business, you have a reframing of value. You say, well, neuroscientists, they don't have tools. Well, yeah, they don't have tools, but today they don't have a lot of value to offer many people, whereas someone dying on a table, they have a lot of value. There's a timeline associated with something very real to them. And so if you can start impacting cancer research and drug discovery and drug development, then, oh my gosh, that's so much more valuable. There's so much more impact. And so we failed in our original market assessment. Did that mean we shut down the business? No, we shifted our direction. We understood that was a failed direction to go after, and we changed our tactics. We changed our technology. We changed our marketing and branding, and went after a different market segment. And we've had lots of other failures. We've failed to hire the right people. We've failed to deliver on certain contracts. But some of those were discovering our own limitations. Some of those were discovering bad customers. Some of those were discovering every different element that you have to discover when you're doing something new. When you're doing something new, everything is a new horizon, and you'll take many missteps. But the point is to take the journey.
Just to add on to that, so imagine that you're working at a company, a startup in Silicon Valley, and what you're working on is it's bad technology. It's not going to work. You don't know this yet, but you're just starting out. If you're afraid of failure and you're not pushing yourself to find out whether or not it's going to fail or not, and you're avoiding it, you're gonna waste your time on it. You're gonna spend years basically working on technology that's not going anywhere. So you have to go forward and push and get to either, is it gonna succeed or fail? And if it's failing, you need to get in the mindset of, I should be spending my time somewhere else, a good technology. I need to find what the next success is.
Yeah, actually, I'll add on something to that, which is there's this strange mentality that a lot of people don't get about Silicon Valley. And they say, oh, you spend all this money chasing down these ideas that don't work or technologies that are bogus or whatever. And they say, why would you spend $5 million over the course of a year or 2 years exploring this thing? Well, the answer is because time is very limited. These funds, they have a limited time horizon. We as engineers, we only have 10 or 15 years before we turn gray and turn into old doddering folks. It's important to get your work done early when you're still bright and flexible and quick of wit. So you want to get there. You want to get there quickly, and it means not wasting year after year after year on projects that ultimately weren't going to go there. And so one of the secrets of Silicon Valley is, again, this fail fast thing that Camille said. The reason they push these companies and these technologies and these people to get to an endpoint quickly, if it's makes sense. I mean, of course, there are some things that take decades to develop, and that's the way of the world. But if there's something that's reachable in 5 years and it can instead be reached in 3 years, well, get to it in 3 years because you'll be there first. And so part of that means sometimes you fail, but sometimes it means you're the first one to get to something very, very new. And that's very, very important.
Nothing to that. Okay. So let's any questions about audience? Yeah. You have?
I like these hands. Keep them coming. Yeah.
So my question is to Cody. So first off, sorry, but I've been stalking all your LinkedIn profile, so a doubt on that. So I saw that your title is Master Chief Engineer. Could you give an explanation on that? And second, your startup is based in Silicon Valley, whereas you're from MIT, and MIT has Dana-Farber and Harvard Medical and all of them right in the backyard. So why start in Silicon Valley rather than there? I can put it as, why is Silicon Valley, is it still that important even today when, the entirety of US is catching up to it? Sorry.
One of the great things about starting your own company is that you get to have fun and do things your own way. I started a company because I considered myself unemployable at the time. I was just not really interested in going into an office, doing the 9 to 5. That just wasn't me. More so now, but we get older. Exactly. So why Master Chief Engineer? Well, one, it made me laugh. So it reminded me of Halo, if you've ever played Halo, Master Chief. But also, what was my role? Well, I wasn't really filling a CTO role. I wasn't the CEO. So I was much more drawn to this idea of the chief engineer. And chief engineers on ships or in manufacturing plants, they kind of are the old wise guy that's trying to keep the whole thing afloat. And so I wanted to aspire to that. And so I felt the title was a more aspirational title. And Master Chief just felt really good. Everybody is an officer, but very few Master Chiefs. The military man appreciates it. So that was the reason for that. And then the second question was why Silicon Valley? Is Boston a hotbed of biotech? Yes, it is. Absolutely. It kind of grew more in that space as I was graduating, after I graduated. San Diego, also a fantastic place. I hear Gujarat is up and coming in biotech, so who knows. But the reason I went to San Francisco is that it was the path of least resistance. Literally, my friend Ted Blackman had just graduated at the same time, and he had gotten into Y Combinator. And Ted was actually the person who introduced Atul and I. And I was talking with him, and he said he got into YC. He's heading to San Francisco. Would I like a ride in his car? And I said, sure. So I had known my co-founder, Todd, and I knew he was starting this business. I initially had a 3-month contract with him to help build the first microscope. And so I said, sure, I need a ride to San Francisco. So I got in his car, and we drove to San Francisco. It's a 3-day drive. I got there, and we started the business there. And it is still just this hotbed of money, intellectualism, art, social environment. And when you need to match up all those things in a small business and a startup, everything is stacked against you. I mean, every big business has every more reason to be alive and do this more efficiently. They already have an HR department. They already have marketing. They already have lawyers to handle IP. All those things are efficiencies that a startup doesn't have. Starting a company is a terrible idea. It's super inefficient. If a big company can do it, they should, and you should go work for them and do it. But not always are big companies willing to take up an oddball mission like automation and pathology. So that was kind of like our vision of this thing. We wanted to do it, so let's go after it. And so when you need to match up money and a unique cross-section of people and be in a sunny environment because you're going to be working long days, so you want nice weekends, to put all those things together, San Francisco is a very, very nice place. Yeah.
I just underscore what Cody said there. So part of my role, part of my job, and what I do now is I visit universities all over the world. I visit innovation centers. I get to travel a lot and see the infrastructure that cities have to do these sort of like incubation type and startup type environments. And I think Cody really characterized it well. Silicon Valley is particularly special because of this cross-section of different expertise and specialties that has been built up over the past few decades. But the other thing that's really interesting about it is it has a culture around creativity and failure and just a kinetic energy to it, where you have a lot of very bright people bumping around into each other, combined with funding and resources, infrastructure and resources, that is the perfect storm to create something extraordinary. And so I've been very impressed traveling around, seeing what a lot of other places have done, and these are really great places to start companies as well. Not to say that there's not other cities where you can do that, because there certainly are, and we're seeing that happen. But there's something unique about Silicon Valley and the history and just the infrastructure and the people there that make it just particularly well suited for startups.
And I think that kinetic energy statement is really important, especially being here in India. I don't know if it's been here for a while, but there's a lot of chaos in India. There's a lot of kinetic energy. There's a lot of dynamics. And there's a lot of potential in that. There's so much that can happen here when you are always bumping into people. Just the first night we were here with Atul, walking from the student center with a cup of chai back to the faculty complex. We ran into 5 interesting, fascinating professors, and also a friend that he hadn't seen in a while from IIT Kanpur, yeah. And we ended up spending the whole next day with him in Ahmedabad, learning about India's history and traveling around to shops. And it's like, that kind of dynamic environment is very powerful. It is one of the greatest pieces of India. And one of the things that I really relate to about with Silicon Valley is there's this like bumping into people and doing things with them and working with them. And that flexibility of environment is really powerful.
I think Dan wants to.
Yeah, I was going to say that I take a slightly different take on this in that I disagree. So I think that Silicon Valley is special, but I don't want to put it on a pedestal so much. Yeah, so I want to say so my company did start in Boston, and ultimately we moved to Denver because we were chasing industries. So to sort of Cody's comment about larger companies solving these problems, if they could solve them, they would. Working with larger companies as a small company, if you're a small company and your ultimate goal is to be sort of acquired, or if your ultimate goal is to, ultimately you've developed a piece of technology, if you're in aerospace and you've developed a piece of technology, you're not necessarily going to compete with Boeing. You're not going to suddenly start churning out, just $200 million airplanes next week, or next year, or next decade. And so you have to find a way to kind of make that piece of technology successful in the ecosystem of these larger companies, and that really means that you need money. It doesn't. You're not going to start it in your garage for very long, at least. You're going to basically take money to develop this piece of technology, and then ultimately you might end up where the industry is. That's what we did. We went from Boston, then we moved out to Denver, where there's a wind industry, with the goal of starting to make some of the cooperative agreements that we needed, some of to sell the technology to what would be the end user in our case, which is the original equipment manufacturers. Silicon Valley, I think you're right in terms of history. Silicon Valley has a history of this sort of entrepreneurship, and that's attracted huge, just ridiculous sums of money. And so the money that's floating around, you alluded to just spending, $5 million in a year and then ultimately failing, like it does contribute to sort of an ecosystem for innovation. But I think the magnet there, the reason that you run into people who are so multidisciplinary, that there is that sort of kinetic energy to it, like really is inspired by the money. And one of the things that's kind of interesting now is that there's almost too much, and so people are being pushed out. So now Denver is sort of coming up as being sort of a place where money. VC firms are starting to go, and small companies are starting to go. And New York as well is starting to be a place where VC companies are starting to go and small companies are starting to go. So I really think that Silicon Valley is an interesting place and it has fantastic weather, but it's really the investors who are willing to sort of take a risk on this investment strategy.
I think we had a question there.
My question is all of to you. Essentially, I'm curious about your perspective about having a direction and focus on problem solving. Essentially, how much do you jump from problem to problem? I'm not talking about the knowledge breadth and depth, essentially about the problem solving and sticking to same problem versus trying to explore multiple problems.
Your question is,
Do you try to solve one problem at a time, or try to jump to a different problem if you're finding something difficult? So
essentially having a focus on singular problem solving for a long period of time versus jumping on different problem solving little bit at a time.
yes. I think both. I think it's one of the lessons that I learned early on when I was a student is that if I put my problem set off until the end, then I will not do a good job. And that's not because I have the same number of, or I won't have the same number of hours to dedicate to that. It's because I haven't had enough time to actually digest the problem, even if it's not real time thinking about the problem. And that's true as well in my professional life. I need to start a problem. I get to a place where I can't think about the problem anymore. Then I start working on the next problem. And luckily in small companies, there are infinite problems to work on. And then after, some time the next morning, sometime sort of with that in the back of my head, then it's easier the next day. So it's kind of short bursts of intense activity. And obviously I try not to overload myself too much with too many things to work on. But if I need to stop and I can't solve it, then I stop.
So just small follow-up question. Essentially, what do you imagine some years down the line solving different problem that you are solving right now for the company or the field of area that you have chosen so far? How long do you think that whatever problem you are trying to attack today, you'll continue doing that?
Okay, so this was a little easy for me because last year I left my company and moved to the Bay Area. So the company is still in Denver and I moved to the Bay Area. And so for the last year, I have been thinking about the next problem, thinking about the next thing to work on, sort of the next place to put a lot of energy. And for the immediate future, for what I've been doing over that time, that's been really doing a lot of research. Research is a generous term here. It's been doing a lot of reading. Trying to think about active problems, think about where my excitement lies, where my expertise might contribute, trying to meet people who are working on those problems, meet people who are interested in investing in those types of problems, and just really understand the ecosystem around them. I wish I could tell you how long it takes to jump to the next thing. I'll tell you, when I was thinking about jumping to the next thing, when I was thinking about transitioning away from my other company, it took me a long time to kind of come to that decision. And there's, of course, a number of reasons for that. One is, just working so closely with people. Like I said, the community is a very, very important thing. So working closely with people, it's challenging to think about leaving that community. The other is working so closely with the problem. You get so close to it that it's challenging to think about stepping away from that problem. And for me personally, it was ultimately the realization that I just, I was not excited about learning the next thing I needed to learn to kind of keep the company going. So it would be better for me to bring someone who kind of had that excitement into that role and sort of find the next exciting thing.
So, you want to talk? Moving on? Can we move on to them? So moving on, so I had the opportunity to work in a small company that made fuel cell systems. So one of the things that we often used to talk about were the known unknowns versus the unknown unknowns, right? So I want you to touch upon that, maybe citing an example from your own work. And also there's this, so based on what we discussed, we seem to indicate that a lot of breadth is good, but at the same time, we need expertise to solve specific problems. So can you also talk about how problems are solved when people with varied but deep expertise come together, rather than one person having a breadth? So perhaps these are two different questions, but in my mind they're connected. So maybe you can talk about it. So you want to start? Okay.
Well, I was thinking about the bringing experts together part. And Silicon Valley actually has a big problem with young people, and that it sees them as the paragons of the future and often won't hire anyone over 35 at a company, which is an utter failure. It turns out people over 35 have a lot of experience in utility and know what they're talking about, and it's good to keep them around. So even though there's this fanaticism for the youth, which I think is great, young people do have very new ideas and do come up with innovative techniques and whatnot. I think having experts, which generally tend to be older folk who have, I think expert and intuition go hand in hand. An expert is someone who doesn't have to spend a lot of time on a problem. An expert is someone who intuits what shortcomings and shortfalls your solution might have and saves you a lot of money in the long run, even though they have a very high salary. So one of the reasons you don't tend to have them in small companies when you first start is that they're expensive. They have 2 mortgages and a wife and a kid and whatnot. But I think how you find experts and start to gravitate them into your field, into your company, is that you make a consistent message that you can put out there in the world that people resonate with and understand and care about. And they hear your message and say, wow, you've been saying that for several years now, and people are starting to believe you. And that's what happened with our company, is like we had many years of saying this thing and people saying, yeah, that doesn't really sound interesting or useful or important at all. I don't know why you're working on that. And then after several years, they say, oh, hey, I actually had a problem in that space recently. And oh, wow, you solved something for someone I know in the field. That's really cool. And there's a publication on it now. I saw that in the journal. So they buy into your messaging. And so I think one of the things is having a consistent mission and a consistent message that you can put out there in the world, and that propagates out like some infectious disease and comes back to you, means that people start to buy into your cult, your idea, whatever it is that you're putting out there. And starting a small company is kind of has this like cult-like aspect. You're trying to get people to believe in something that's kind of irrational because it doesn't exist yet. And so how you draw experts in my area, is that you put out this thing that's unbelievable or irrational or weird. You become your own expert in saying that. And then other experts from other disciplines see that that's important and valuable and start glomming onto it and coming into it and wanting to help you with it because they start to see the value in it too. And then once you get those experts together, then you've got something that's very powerful. And we finally started getting to that tipping point where people who actually know what they're doing are joining on with us and helping us avoid mines in the minefield. I'm sure it's very different than in the medical field or established company.
Well, I think so. What's been interesting about our company, so we recently actually hired on some immunology experts. So my line of work is in radiation physics. It's shooting radiation at a tumor and killing the tumor. What's really interesting? I keep missing. Thanks. What's interesting now about where that field is going is there's a lot of really curious work going on in the immune system, how that interacts with radiation, and if you can effectively pair those two in order to have a bigger effect to kill the tumor. And my company did not have experts in biology, in radiobiology. And so we hired on an entire team of experts in this space. And so I'm a huge proponent of multidisciplinary teams, people who bring knowledge and expertise from different backgrounds in order to intersect and solve a problem. And so it really kind of goes a little bit to what you were talking about with the known versus unknown. So, what we try to do is we try to take a step back. We have experts in our field to try to take a step back and at least try to identify what are kind of the main pillars of oncology and where is the field going, and then look internally, try to figure out where do we have expertise in this space and where do we need expertise, and then try to fill in those gaps and have crosstalk. So that's actually worked very well for our company. We actually have some really interesting and exciting innovations coming out of just that crosstalk by bringing in that expertise. But I think what's really important is acknowledging that multidisciplinary teams really bring in, it's like it amplifies your solution space, because you have just this coming together of ideas that you would not, that make these reactions that you wouldn't have otherwise.
I think about an interesting follow-on to that, just sort of hearing that with your quadrant of, you have known knowns, which are easy to account for. You have known unknowns, which are problems that you need to solve. You need to do something creative. You have unknown knowns. Those are things that other people know that you don't know that you need to know. And that's where experts are really helpful, because those people already know those things and you can hire them. And then you have unknown unknowns, and those are the really dangerous things. Those are the things that cost a lot of money and you need investors for. And so you can kind of put together this picture of like, how do each of those pieces fit together to form some solution that you're looking to apply to a problem? And you can assign different kinds of accounting. One of them requires just like simple engineering. One of them requires creative problem solving. Those have certain budgets associated with them. Experts are going to require finding out which experts you need, bringing them into your team, and then understanding how to apply them. And then the unknown unknowns are, that's the magic.
And I'll say all of these unknowns of all flavors are all things that you don't know generally beforehand, especially when you're young and stupid and you're starting a company. And so they always cost you money and take you time. So everything is always late and it costs more than it always should.
And that's okay.
And that's because you run into one or more of those unknowns.
I just want to add on about the second point. So there's two types of people. There's the people who want to specialize, and then there's the people who want to have a broad range of understanding or specialization in a couple things. And those, you'll find out eventually which one of those you are. And a company, basically, it depends on where the company is, what stage the company is, and how you'll fit in there. So like, for example, when a startup is starting up, they need people to wear a lot of hats. They need somebody who can come in and isn't specialized in one specific type of part. They can run around and do all sorts of things, and they need to think outside the box, and they're a generalist. But then as they grow and they start hiring more and more, once you get to like 10, 20, 30 people, they're looking for experts. They need to hire someone, not to do a bunch of things. They already have 30 people. They need to hire someone who can solve one specific problem for them. So
I was going to say, that sounds like leadership. I think that's where leadership comes in, right?
Yeah.
Being able to balance those things in a group, which is something we haven't really talked about. We should talk about it, yeah. Leadership. It's kind of a creative problem space. I don't really know what your leadership experiences are like here at IDIT, but I think that's one of the other sides of things that is really nice about MIT giving a little bit of space and acceptance for play and creative work, artistry. We talked about art a little bit earlier today with a subgroup of some people, and I have to say one of the great things about art is it teaches you a lot about leading your own project, leading your own desires, seeing what's inside of you and how you want to express it out in the world. And there's leadership is an art. It's not something you just pick up a textbook and now you're a great leader. It requires the experience of doing things. It's like engineering, that you're going to fail a lot, but it has a lot more communication and chest thumping and making big speeches. Again, the humanitarians are important here. But in a company, you might be in a company where you find that they're not switching from breadth to depth of their people. You might find that there's misallocation of resources. Being able to identify those things and communicate them, being honest about them, is the first step of leadership. And I think just like first communication, awareness, and sensory engagement, those are really the first steps of leadership. It means just being aware of the place around you, seeing the people around you, hearing them, and then thinking critically and giving the space for yourself to be a leader. And that is one of the most important parts of engineering is, you're not just at a desk. Ultimately, you're designing things that are going to impact people's lives, and you're leading by manifesting those thoughts. You're leading them with what you design, with what you build. When you create something, it leads, you build a bridge, people will be led to drive across it. And if the bridge is not strong enough, there will be consequences. So think about how your design and your engineering are leading people to certain outcomes. This is very important, and that's the duty of an engineer.
So, switching topics a bit, students who came to me said they want to talk about technical aspects. So perhaps you could talk one situation each about a technical challenge that you faced that took a lot of your time and energy and money, and then ultimately you could figure it out, and perhaps you could outline how you did figure it out. So perhaps we can start with you.
Okay, this is a common interview question, so get prepared to hear this in interviews. Can you describe a technical challenge? So the most recent technical challenge we had was so what I do for the engine is I am the lead of the injector, and the injector basically injects fuel and oxidizer into a chamber, and it does it in such a way that you combust smoothly, efficiently. It's kind of the art of the engine because fluid comes in and you have infinite number of ways to lead it into the chamber. And we were testing this engine, and we were having an instability. Basically, it's called a chugging instability, where you flow your fuel into the chamber. It combusts, and your pressure rises. But then the pressure rises in such a way that it stops the flow. So then it stops combusting. And then so the pressure drops, and then it flows again, and you repeat, and you see an oscillation basically, and it's very bad, especially at high power levels. It can destroy your engine, and we tried all of these different things to try to fix it. We changed the design, we changed the temperature, we did all of these things, and we eventually drew inspiration from our house that we have. So basically, one of our fuels is a liquid. It's liquid oxygen, and it acts like water, basically. And so when in an old house, when you used to open up your tap, the water would flow through, and then you'd close it, and the water would just slam into your valve. It would have nowhere to go, and it would go and have a huge pressure spike, basically. And so on our stand, we were seeing something similar to that. And now what they do in your house, basically, is they put basically a glorified tube over it. So when you close your valve, the water can flow into the tube, which basically just has a cushion of air there, and it can dampen it out. And so we found that by adding this, we were trying to solve a different problem basically at the time. We were trying to solve that problem of water hammer basically. But by adding it, we had added this cushion of air, which was basically attaching to the chamber, and it was talking to it, and they could resonate back and forth. So we found out it wasn't the engine at all. The engine was not the problem. It was our test stand. And so what we did is we had to actually tune out our tube and change the size so that they weren't talking to each other anymore. So it took a while. You had to actually think outside the box. It wasn't the obvious problem. It was something else way upstream.
I work in instrumentation, mostly. That's where my engineering skills lie, or machine design and instrumentation. I can give you hundreds of technical problems that we've run into. A lot of them are vendors. Vendors will be your life and death. So, and I mean that very honestly. There's a reason there are people like Elon Musk like to in-house their various parts as much as possible. It's my understanding at SpaceX that they in-house a lot of things, not everything, yeah. So like in-housing things is great because you don't have to rely on vendors, and vendors will, they won't lie and they won't cheat, but it's difficult to communicate between engineers because they're not great at communication. And so you write a specification or you make a drawing and you hand it over to someone, and there's room for misunderstanding. There's room for not communicating the full scope of the thing. If they aren't the designer, if they're not the end user, they may not see to it. And from their perspective, you're another job on the list. You're just someone that needs a part, someone that needs something designed, something put together. And so your vendors can really be your life and death. I would say our biggest problems in instrumentation is that you cannot be an instrument designer and manufacture your own cameras. It's impossible. You buy them from Sony or Teledyne or the other big manufacturers. You can't make your own light sources because it doesn't make any sense. So you buy these things from people. And systems integration has been the biggest hurdle for many of our projects. I would say ground loops, having port grounding. It sounds like a dumb thing, but ground everything in your projects. It'll make your life a lot easier. Add extra ground cables.
I second that.
Yeah, scratch the paint off the corner of every one of your cabinets when you bolt it down. It's this little intuition thing, but it turns out that grounding is a huge problem. Firewire errors, we have one stage system that throws a firewire error every sporadic 8 to 24 hours. I've never figured out why. I've tried to correlate it to the air conditioning, solar flares, building power cycles. None of them have been a hit for why we have these firewire errors. I have no idea why they're there. It's been 3 years. So I would say like system integration, the software and the cabling and the intricacies of integrating a system is by far the hardest thing in instrument design. The rote pieces of designing an instrument, of doing some high-end physics component or an imaging instrument or whatever it is, those pieces are tractable. You can understand them. You need to hit a certain signal to noise. You need to be creative, yada, yada, yada. What will slow you down for 2 years is just wiring everything together and not getting grounding issues and poor cabling and some vendor who lied about a specification on a motor torque. And it turns out that motor torque only works if you use a 500 volt power supply that like you can't buy and would be super unsafe to operate inside of this environment. So really question your vendors and also develop good relationships with them. Back to relationships, like you're working with people and you need those people to work with you, but also work for you. And part of that establishing leadership in engineering means knowing what you want and being able to say it with conviction to someone. And then if they don't deliver, you kind of have to poke them a little bit.
So, yes, system integration. Yeah, absolutely. So I'm going to give an example that is, I can think of many examples. Part of my work when I was working at the cancer clinic was quality assurance of very technical machines. And so you're chasing your tail on problems. But one that stands out in my mind as a very interesting problem, so in radiation oncology, we have these big linear accelerators that you put an oncology patient on a couch. They lay horizontally, and then you have a beam that basically you accelerate electrons. You shoot either photons or electrons at the tumor, which is inside the patient. And so in order to align that beam with where the tumor is, you have to do some sort of imaging of the patient as they're laying in their treatment position. And so that's fine with tumors that don't move, but it's very challenging with lung tumors, pancreatic tumors, liver tumors that are moving around because the patient is hopefully breathing while you're treating them. So one of the challenges we had early on was how to develop a system where you could visualize where the tumor was in relation to the radiation beam, because you can't see the radiation beam. And so we were very challenged with how to do this. There were vendor solutions, and this is again when I was on the clinical side. There are vendor solutions that allowed you to have kind of this digital outline of where the beam was going to be as you're looking at a two-dimensional picture of a tumor moving across the treatment field. And those did not work well because the systems did not integrate well. So what we ended up doing after scratching our heads for quite a long time is we ended up taking some wire and we put it on the imaging panel. And the wire is very easy to see on the imaging panel. If you line it up correctly where you think the beam is going to be, you end up having a static aperture, and you have a tumor that you can see moving in and out of this little wire outline. And so if you correlate that with where you know the beam is from your geometry and your software, you can actually visualize the tumor moving in and outside of this little wire contour, which correlates with the beam. And it's a very simple answer to a very complex problem. And I think what was really fun about this is, first of all, it took a team of physicists and physicians to all work together, and then the patient being very patient on the on laying on the treatment couch, for us to come up with this solution. And we had to iterate through kind of different designs in order to get this right. But I thought was really interesting about this is we just went back to first principles. We have these very, very complex treatment systems, and what we do, it's a very highly it's fantastic technology, but it's very complex. And so, at some point it just wasn't serving our needs. So as engineers and problem solvers, we just went back to first principles, and it ended up being the answer we need to solve the problem. And ultimately we were able to treat patients more safely because of that. But, it goes back to having a fundamental understanding of, of your field. So.
Okay, so unfortunately, I think the hardest problem that I tried to solve was of my own creation entirely. The early in the company, we had we wrote down a list of requirements that we had for this control system we were building for the machine, and one of the requirements came down to sort of interoperability of that control system by people who are experts in controls, but also people who are mechanical engineers. And we wanted to make something that was going to be like easy to work on for everyone. We wanted to use like a language that everyone would understand. And so we chose to use MATLAB to write this control system, which turned out to be an absolutely terrible choice. We tried to integrate a number of different third-party systems. We tried to basically write our own communication system. At the end of the day, we had a system that was functional. We more or less extended MATLAB, basically made our own language. It was extendable, it was compilable, it operated, it was understandable by no one, it was fragile. And it didn't allow us to build anything on top of it, really. And the hardest part, I think, was kind of coming to terms with that failure, understanding that we needed to switch course and do something different, and then just putting the time in to actually switch everything over to sort of the next thing. So it was really kind of self-imposed. I mean, and it stemmed from basically a set of bad requirements. If we had been more, if we had given more consideration, if we had really like narrowed the set of requirements that would solve our goal, instead of trying to say, well, it needs to do all of these things. If we had said, actually, it only needs to do, really 4 things instead of 10, then we would have come up with something with a better solution, more elegant solution. And we wouldn't have wasted basically so much time, or had to kind of circle back and sort of reinvent technology that we had already invented.
I'd like to just quickly add one final thing. So something that I learned with solving problems that has saved me so much time now that I do this is whenever an issue occurs and we have no idea what's causing it, the best way to solve it is to first get on a whiteboard, write down what is the issue, then get 3 or 4 people that you trust or who are involved in the project, and just brainstorm what are possible issues, what could be causing this, anything at all. Just make a long list, and then figure out, okay, well, how do we test these? So a lot of, like when I was first starting out, we'd find an issue and we'd be like, okay, well, this might be this one thing. And then when we'd stop thinking, we'd just try to figure out if it was that one thing. And then, okay, it wasn't that thing. And then you'd say, okay, well, maybe it's this other thing. I mean, just from the start of it, write down what are the possible root causes, and what are the easiest things to check, and just have a framework for solving the problem.
Yes. So, are there any questions from the audience? We have had 2 questions from you, so we'll go to her.
Hello. My name is Archa. I work in a Ahmedabad, Cambridge, UK-based company. We also work in technology as well as science. My question is in general. My company in India has a big issue in getting women employees. It's our target to have 50-50 women and men ratio in the office, but we see a big difficulty in hiring women employees, which I see is the same in the room also. There are very less girls. Is that the same problem that you also see in that part of the world? If yes, how are you guys trying to resolve it?
I'll start. I think in both our fields, that's a big problem, yes. Aerospace is mainly men, and some larger companies are run by people who may not view women as the best engineers, basically. And for me, it's basically just coming down to finding people who don't think that way. Like, I have a choice. I can work with people who are stuck in the old way of thinking, or I can work with people who don't think that way. And that's the best solution, I find. Like, find a company or a culture that encourages women engineers, or and just work with those people and help each other out.
Yes, this is definitely an issue. I'm fortunate enough to work for a company that has a very strong female presence, and actually our president up until a couple months ago was it still is a woman. One of the things that was really, I think, was really smart in the way that she recruited was she sent out female representatives to speak to what it was like being a female in that space and working for this company. It's can be very alienating to have conversations with men who may not understand some of these issues that females have in this environment. So you know, there were a lot of initiatives that she led throughout our company, raising females through the company and empowering females. But I think just seeing a representation of females in the field was really powerful for me, and having making a point to make sure to have that representation as you're recruiting females is really key. But it is a problem, and it continues to be a problem. And you know, in some companies, you actually have females who are paid higher than males just to try to recruit that talent to come in. So like the pay gap is even reversed because they're trying to recruit females to come in.
Yeah, and
another question.
I want to spend a little more time on this because it is a very important and serious issue, and not seeing enough, as many women students here in the lecture hall, it's something I think about a lot. One of the things at MIT that was powerful is there's essentially a 50-50 gender ratio in the undergraduate population at MIT. And that I thought was incredible. It's very empowering to go to a top-tier engineering school and see women very well represented there and having an equal place. It was very influential for me because I came from a totally non-engineering, non-academic upbringing. And so my first introduction to engineering was that women and men were completely equal in the education process. I feel very fortunate in that because as you get into industry, you see attrition. Historically, it's a shame because the foundations of computer science and many sciences were all many female pioneers. And coming back to what Camila said earlier about multidisciplinary teams, having all people represented, all women and men, having different races, castes, etc., all represented in a work environment means that you come up with much more creative solutions. Each is an expert in their own domain and their own perspective, and having different perspectives represented gives you nonlinear and better solutions. So one of my hopes is that a team made of diverse people is able to come up with solutions in a much quicker fashion, and they're much more efficient because they have different perspectives represented. One of the fortunate things is running my own company. I get to try and hire. So one of your question was, how do you recruit and how do you staff? What I try to do is I find that traditional hiring methods don't present equal numbers of candidates from both genders, and so I try to find alternative ways to recruit. There are a number of female-oriented meetups. What do you call these events? Like the thing that you had at the hardware thing, at Bolt. Yeah, not, what do you call them? Like a meetup? Yeah, it's like networking events. And so like finding those and making sure that there's a clear and concise communication environment there where it's like, okay, there's an email list and every job posting should go out to the email list so that like women are aware of the fact that there are more job opportunities available. And it's not just like whatever job you happen to be in, you hate your boss, you quit and move out of the engineering and sciences. It should be that there's a place where, and one of the things, like I'm not a woman, so it's harder for me to just say like, oh, you should go do this. But as women, if you can, find these areas where women are represented and form a clear and concise communication channel there such that you can be more efficient in that domain. And I don't know what that looks like for you in your field here. I don't know Gujarat as well. But that would be a first step, is one, making a presence and a name where women can meet up and network. And then two, using that networking as a tool. Make an email list, send out every job posting, make a culture of sending job postings that list. Because if there's more mobility, if the people can transition jobs more often, they will rise quicker. And as women rise in companies, more diverse companies are more effective, they're more efficient, and ultimately, if capitalism prevails, they'll win out. So I would say that would be my best thoughts. Is come to here, lead female networking events, and keep that community and culture tight knit and with good communication. And hopefully that helps.
To add on to that a bit, when we first started this company, Stratalaunch, it was equal women and men. But as we grew and are hiring and interviewing, basically there are just not that many women applying. So of course we're hiring to hire the best person regardless of gender. But as a woman, I do want to encourage other women engineers, and I do want to help them out as much as I can, of course. But if 10% of the applicants are women, basically that's the problem, right? And how do we fix that? I mean, we can't fix that today, but what we can do to try to fix it for the future is do outreach, basically. I mean, go to these, start events, we need to meet with young women or young girls and show them that there can be women engineers out there and they can be successful.
There was a
Can I'll go back to the subject of success and failures in life. Every failure is something that you don't want to repeat again in your life. In India, a failure attaches a certain stigma to your life, to your career, to your family, to your upbringing, etc. How bad or how good is a failure in America? Are you suffering from the same stigma in America? Secondly, do you think entrepreneurs are born, or do you think they're trained?
Do you think entrepreneurs are born or are they trained? So,
Okay, those are two very different questions. So I'll just try to address the first. I think when we were talking about failure, we talked about really two things. The first is kind of failure as a company, or failure from a sort of like as Cody said, you're framing what your success is. And the second is mistakes, things that you just did wrong. That is it a failure? I don't know, but you made a mistake. And I do think that there is a stigma to that. Certainly, and I think ultimately, like maybe that's socially imposed, but in the U.S. also. But it's also just no one likes the feeling of having made a mistake. There's a saying, if you're not making mistakes, you're probably not making much at all. And so I think it's important to kind of get past that, just beating yourself up about it. I think it's important, to just kind of personally make peace with it and sort of move on. But certainly in the US, no one likes to make mistakes.
any other question from the audience?
What's that? I was going to add one quick thing there, is the stigma thing. Definitely, if you fail too many times, there is a stigma, right? That none of what you've done is successful. And I also understand this, that there's a bit of a difference in the East, that like a failure has like this guilt or personal responsibility to it. I think one of the things that I've learned is what you're responsible for and what you're accountable for, and that those are two different things. You can be responsible for a failure, or you can just be the person who has to account for it on your books. And if you're trying out different products, if you're trying out different ideas, those are all things you may have to account for, but you're not responsible for them in the sense that it's not personal. And there may be societal guilt that people try to inflict on you, but you don't get into entrepreneurship because you listen to what other people say about you. You have to have thick skin, and there are times where it hurts and where you're going to feel like no one trusts you. But I think that's where the honesty comes back. And having clear communication and having people that you work with in the community who understand you and who understand you closely and understand that what you're doing is honest work, and that those failures were done in an honest way. That's where you can be accountable for them, but not responsible for them.
And then, like you were saying, that accountability. I mean, that is, I think, a key component of what is being an entrepreneur, or being, someone who's just trying to start a business. And so, is an entrepreneur born or made? I don't know. I mean, I think that you, in one way or another, you have to develop a thick skin. You have to develop an appreciation for sort of the broad education that we're talking about.
I think I can comment that too. So the startup culture in India is growing. It's still not very big, but it's growing certainly. And the people who are in startups today were certainly not groomed or certainly not born as people who were entrepreneurs. So they grew into and they got attracted to the startup culture, especially in cities like Bangalore and so on. So I guess I would say it's environment training and also your own perspective rather than being born. So, so any other question from the audience? And if not, we can close the panel discussion with a lot of thanks to our guests, and thank you very much for taking the time out. Thank you. So,
Yeah, thank you all so much. It's been such an honor to be hosted here. The campus is beautiful, the people are fun, and the chai is great. So I've been having a fantastic time.